name is Penny. I'm here to talk to parents about the Fibonacci sequence and ways of getting 9 to 10-year-old children involved in thinking about the natural world in terms of mathematics. I'll be chatting to you about fun ways to engage children in exploring this number pattern through educational play. Maths doesn't have to be a cold, boring chore where you tediously calculate all day. It actually can be quite interesting and surprisingly beautiful. How, you might ask? What if I told you there was a fascinating number sequence found in many of nature's miracles? After all, maths was created and based on nature. It's called the Fibonacci sequence, and it's present in plants, animals, the human body, DNA, solar system, art and architecture, and much more. The sequence was identified by a mathematician from the Middle Ages called Leonardo of Pisa, or Leonardo Fibonacci. One reason that the Fibonacci sequence is great to work with is that it is very easy to calculate. It starts with 1 plus 1, which equals 2, then the last number is added to the one before it in the sequence, so that would be 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and so on. These numbers can be used to create what is known as the golden rectangle, giving rise to a pattern known as the golden spiral. Fibonacci numbers are applicable to the growth of many things found in nature, including the number of petals and seed heads of most flowers, sections inside fruit, leaf arrangements, scales of pineapples and pine cones, ferns, succulents, shells, grain, beehives, hurricanes, and even the Milky Way. It is thought that nature embraces this pattern as it's the most efficient way to grow and maximise the use of space. Another interesting maths fact about this sequence is that if you divide a Fibonacci number by the one immediately before it, the result is approximately 1.618. This value is referred to as phi, or the golden ratio. This ratio is evident in such things as the nautilus shell, dolphins, starfish, the human body, for example, our finger and facial measurements, our outer and inner ear, just to name a few. Well, now that you have a background in what the Fibonacci sequence is about, let us look at ways to involve children and get them thinking about this number pattern and how it relates to the world around them. I suggest an activity that comprises of 3 main steps. Step 1 will be introducing the children to the actual Fibonacci numbers and providing some visual examples of how they occur in nature, explaining why it is important to study these patterns. Then have the children calculate the first 20 numbers in the sequence on a worksheet, that is 1 to 6,765. A calculator could be used for the very large numbers, as the main idea behind the process is accuracy, because one mistake will mean the rest of the sequence will be incorrect. Step 2. Now that the children can recognise what a Fibonacci number is, they can see for themselves the wonder and beauty of this sequence in action through a Fibonacci flower hunt. The children could be equipped with a chart documenting their findings, plus a list of questions to consider while they explore and collect their data. I also recommend that children record the flowers and foliage through numbering and sketches rather than picking parts off plants. 3 relevant questions you could put to them might be: can you find examples of flowers with petals that add up to a Fibonacci number? Can you find other numbers of petals on plants which are not Fibonacci? Can you identify any spiral patterns on the flowers or elsewhere on the plants? It appears this tactile, real-world approach to learning appeals to children. However, make sure you join in alongside them in the activity and provide guidance if required, as it helps maintain their interest and motivation in the exercise. Step 3. Once the data has been collected, discuss the findings and reflect on the activity. They could then make connections between maths and nature and realise the importance and beauty of Fibonacci numbers in our surroundings. So when you next take time to smell the roses, maybe spend a moment to appreciate the mathematical beauty that has gone into producing such a divine flower. Thank you for your time.
Created using Powtoon.